let's go through the basics of JavaScript, the syntax, and how you actually run it in this second week of web application development. The topics of today are syntax and the data types, operators, conditional statements, if then else kind of statements, loops, for loops, etc., and string operations, how you define strings and how you concatenate them, etc., and also array operations and functions. These are actually the basics of the language, and we will do a comparison between the JavaScript elements and the corresponding Python elements so that you have this picture clear in your mind. So there is this history of JavaScript. This was created a long time ago, and this was supposed to be a method by which you can run stuff on the client side. So as you know, web scenario, you have the backend, which would be your server, and then the internet, the transport layer, and then you have the client, which would be your browser. So JavaScript typically ran on the client side, on Chrome, for instance. And then at some point, somebody extracted it from the browser and made it into a standalone application and called it Node.js. And that could run anywhere. In particular, they could run it on the server side and dealing with the process of serving files to the client. The moment they did it, it became what they call a full stack language. In a sense, you could run it on the front end. You could do manipulations of how you see things on the front end, and also you could do the web serving, and that made it easier for developers to build up their expertise in just one language to deal with everything, the full stack. So JavaScript now runs on all websites. It is very popular on the server side too. So it's a programming language as opposed to a markup language, which HTML is. It can identify HTML elements and then do stuff to them interactively on the browser. And it can actually serve stuff also, as you will do in this course. As you know, WAD1 is a backend course. So here we are actually more concerned with how you actually do stuff on the backend so that you can serve resources to the front end. A quick comparison between JavaScript and Python. Print statement. In JavaScript, you would be using console.log. So each JavaScript program, when it is running, is attached to a console. If it is running on the front end, if it is running on Chrome, then the console is actually something that you can view on Chrome. If you're running it on a terminal, say Node, a JavaScript file, then console will be that terminal. Then how you define variables, we will be using almost exclusively let x equal to 5. So that let keyword is important. In fact, it turns out that JavaScript is actually very tolerant, and if you just say x equal to 5, much the same way you would do that in Python, it would still work, but with a lot of side effects that we may not be able to control. So we will not be doing it that way. So let is our preferred way of using it, and we will also use const, as you will see. Then there is if statement, which has a more standard form compared to Python. Python, as you know, you would use indentations to indicate blocks. In JavaScript and in most languages, you would use braces, curly brackets. A loop structure, a for loop is like this. You declare the initialization condition, you specify the termination condition, and you specify the increment, all delimited by semicolons, and that is the structure. And this for loop is a darling of most developers for the simple reason that you can see everything that is going on right here. You don't have to worry about how things are, how the condition is changing within the loop. And in Python also there is something which to me looks a bit clunkier than the for loop in JavaScript or C or PHP or whatever. Function declaration also is more standard in JavaScript, similar to PHP, for instance. And you know what it is in Python. It is again indented blocks. List or arrays, very similar to Python. And dictionaries in Python, which is a very powerful structure. It doesn't really exist in JavaScript, but we have something that is very similar, which is an object. The difference is that the key, which is a string in Python, is actually a property of an object. The moment it becomes property, it's not a string, so you wouldn't actually use quotation marks around it. So So that's the difference. You will get used to it. Null value is a bit different. And then equality check. There are two ways of comparing two values. The first one is just comparing the values, which means JavaScript, being a dynamically typed language, is free to change the type so that it can do all possible kinds of comparison. Again, you will see examples of that. But if you want to make sure that the value as well as the type are the same, then you would use triple equal to. That doesn't exist in Python. And comments, different ways of commenting. That's a quick comparison cheat sheet. So let's look at an example. So suppose you have an HTML file that, as you know, HTML starts with HTML, ends with an HTML tag, head, and then body. Inside the body, we're saying script with optionally specifying the type of the script, in this case, JavaScript, and document.write. So document is an object, which is actually the object that you're viewing in Chrome. There you're just writing hello world. So this will actually appear as hello world in Chrome. There is a little bit of confusion because JavaScript runs on the client side and in Chrome, or it can run on the server side. So we have to kind of understand or keep this picture in mind where exactly it is running. So I created this little picture for you. So it can run on the front end, which is Chrome, or it can run on the back end, which in our case is Node.js. And suppose you create an HTML file. I called it where.html because we're trying to figure out where exactly this is running. And this is the HTML file that you saw in the previous slide with this red statement there. I am also attaching another statement which looks similar, but instead of saying document.write, I'm saying console.log. So let's figure out where that will appear. So this file, I already have prepared it. So in my week 2, I have this file where.html. Let's try to run it directly in Chrome, which means I'm going to just open the file as a file in Chrome. So let's do this properly and carefully. Here, I'm going to say open a file, and this is my desktop, IS-113 week 2. I'm going to say open where.html. Now I get hello Chrome. It is actually coming from this statement, hello Chrome, and that is the first one. Where is the second one coming from? Now you can see that there is a script in which I explicitly typed some JavaScript, and the second one more script tag where I specified as an attribute the source where.js. So there is one more where.js file here. There I have specified hello Chrome. One is in document write and one is in console log. So going back here, in the body of the document that you're viewing in Chrome, you will see hello Chrome, and again in the body coming from here, you will see hello Chrome again. So that's what you're seeing here. Now just to convince you that this is exactly what's going on, let's go back to the Visual Studio Code and then type in a couple of indicators. So in the JS, I want to say this is coming from JS, so just that tag there, and let me save that. And here I want to say this is coming from HTML. Save that. So as you can see, HTML hello Chrome, JS hello Chrome. That is as you expected. Now we also did in HTML, I also did console.log hello console. Where is that going? And also in where.js, I have the same thing. Where is that going? Let's take a look. In Chrome, I can say inspector. So right click and say inspect, and that opens that. In there, I have console, and there coming from where.html line number 6, I have hello console, and where.js line number 2, I have hello console. So line number 6 in where.html and line number 2 in where.js. So that's where it's coming from. So what we did was to open the file directly in Chrome like that. So what you see, the protocol is just file, which means it's reading directly from the file system. So it's a local computer, your laptop, and then you're just reading it directly from there. But since we are actually working in this server client kind of environment, so you have a local host which is a server, and so you can actually serve this file to the client, in which case it will actually come through HTTP protocol. So let's start up a server which is already set up for you here. How do you start up the server? Just type in node server.js. So that you have to be in week 2, that I am. So that starts up a server, and now server is running in localhost 8000. So I go here. So instead of saying that, I would just say localhost 8000. I don't have to say IS-113 week 2, etc., because in that week 2 is where my server is running. I see hello Chrome, hello Chrome. Again, in the console, I see the same statement. So what's happening is that this time I'm not loading it directly in Chrome. Chrome is actually asking for the file. It's asking localhost import 8000, give me this file where.html, and that gets intercepted by server.js because that guy is listening in 8000 localhost. So it captures that. The details of how exactly this is being served you will understand later, but there is a mechanism by which it is actually served by server.js. That's the important thing. The difference between getting the file from the server using server.js or opening it directly for our purposes here is actually quite minimal. In this case, it's quite minimal. But we can run any JS file using Node directly also, which is why I had the script in where.js. So let's try running that directly on the server and see what happens. Right off the bat, I can tell you that it's not going to work as you expect, but we will make it work. So we can say, instead of saying node server.js, we can say node where.js, because where.js is a file right here. Right away, you have an error. It says document is not defined, which is the way it should be, because document is something that you have on Chrome on the client side. Here there's no document because you're on the server side. So document hasn't been constructed yet. So all you have to do is to comment out that statement, because document object is not there. So comment that out and run it again. This time it actually runs and it says hello console, and that is coming from line number 2. This time, just to convince you, I'll just say JS as a tag there, save it again and run it once more, and it's coming from there. So in your lab test or when you're doing development, most of the time you will be running stuff on the laptop directly using Node.js, just the way you saw here, because right now we are concerned with the backend. Backend is your laptop where server.js resides. So the bottom line here is that you have the facility to run JS in the front end that will be using the JavaScript engine on the browser, or you have the facility to run it on the back end where you would need Node.js, which is why you actually installed it in the last class. So that is just an overview of where things are running. In order to declare a variable, you could use let or var, and then of course there is const. Our recommendation is to always use let whenever possible. Const also is liberally used, but var should be avoided at all costs, and there are reasons for it. We will get into it in a second. I have to tell you that there is one more way of doing it without let or without var. Just saying it like this also will work, which is even worse than actually using var. So that should never be used. This has got something to do with how it pollutes all objects in the scope, etc., by creating automatically some properties in them, and those things are all very bad. You shouldn't let a computer language do things that you don't explicitly ask it to do. Anything that it does behind your back usually leads to errors and bugs that are very hard to track down. So assignment is as you can imagine, and then you can have the usual operators, plus, minus, star, slash, etc., etc. Then comment characters, single line we use that, multi-line you would use this. Those are all fairly standard in most programming languages. Console.log, as you saw in our little example, is how you would look at the value. So if you want to debug JavaScript, typically you would use console.log, but there is a built-in JavaScript debugger in the browser, so you could use it in the browser. This of course doesn't exist if you're running it using Node on the server side in the backend. Obviously you don't have access to the browser console, but if it is actually being run on the browser, you could use the console. So let me just show that to you to be sure that we understand that. So we have where.html now being served by my server.js. Let's just make sure that server.js is actually running. It's not. So let's run that. Now it is serving, so we can reload this, and now I see only one hello Chrome. Because why? Because remember, to make where.js run properly, we commented out this guy, so that's fine. Actually, let's comment that in or uncomment it so that we have something else there. Now let's also have let x equal to 5 console dot log x. One more, console.log x star x. Just a couple of statements, nothing fancy here. Save it, come here and run it. So JS also says hello com, and then you see 5 and 25 there. Now how do you debug this? Suppose there was an error there. So let's go to sources. Then this guy is where.js. I can click on it and I see lines that I had in my Visual Studio Code because this file was actually served by my server.js and it came to the browser and the browser actually ran it. I can actually set a breakpoint here by just clicking on the line number, and if I reload this, it actually goes and hits that and then it stays there. Then I can actually step over or step into if it is a function or just continue run. So let's step over that statement, come here. Now let's look at x. X is 5 and that is there in the local scope where it says local scope here, x equal to 5. And in global, there is window with a lot of stuff. And if you had not used let there, what it would do is actually pollute this window object and put a new property called x, and it creates a mess. So always use let, not even var. Var doesn't actually pollute the global objects, but it is almost as bad. Its scope is actually a bit too big. It's bigger than you want it. Now I can just run and then I'll get that. So there's another way of debugging. So something that you have access to if you're running the JavaScript code on the browser. Now keywords, all of them actually, JavaScript is case sensitive. So you have to be careful about the case. And one of the things I saw was that some students were using username with N capitalized, which is the way it should be. Then they were trying to access it with username with U capitalized. That will not work. So var, try not to use it at all. Always prefer let to var. Then const is actually to declare a variable that cannot be reassigned. Typically things like pi or some number of students in a class, etc. will be const. They are semantically constants. But also, if you want to define a variable that you don't want to change, you can actually use const, which is actually very common in JavaScript. Then if, else, etc. You know what that means. For loop, do while loop. If you're in a loop, if you have the statement continue, JavaScript doesn't execute the rest of the statements in the loop. It jumps back to the top of the loop. But if you want to break out of the loop, meaning you stop executing the loop at a point and then come out of the loop and start executing the statement right after the loop, terminating the loop, and that would be break. Then of course function return is the way you would exit from a function. And then there is this try catch block that I'm told you have already learned in Python, but we'll go through that again. Use let, that is the statement here. Problems are multifold. The first one is that if you use var, you are allowed to redeclare it, which is ugly. It should not happen in a programming language. But if you use let, then it wouldn't let you do that. That is one thing. Then the other thing is that the declarations are hoisted, but the assignments are not. What that means is that if you have this, just this in a JavaScript file, because you have var x here, the allocation of x as a memory location and with that label will happen near the beginning. That is what hoisting means. It goes to the top of the scope. So x actually exists, but it's not defined. The value is assigned at that statement. So this is all a big mess. But if you use let here instead of this, if you had used let, then this statement will throw an error. You might think that errors are not good, but errors are actually good. If a program, your code, is supposed to fail, you would want it to fail as soon as possible so that you have a chance of fixing it. If it waits till you release it to the whole world and then fails, that is a black eye for you, but you would like it to fail right when you make the mistake. So this would be a mistake and it should fail right there. Score in this case is a variable defined by let, so you can reassign it, but pi in this case is a constant, so you're not allowed to reassign it. So as you would expect, const is for constant. Now naming convention, the preferred naming convention is actually what we call camelCase. CamelCase, which means you will start with a lowercase and every time it's a new word you would capitalize it. So username here, N is capitalized, total price here, P is capitalized. It is called camelCase because to some very imaginative developer, this looks like a hump, which is like the hump on the back of a camel. You should remember that a variable cannot start with a number, but it can start with underscore or even $sign. Functions also we will be using camelCase, and try to make the function names mean something, meaning use action verbs to indicate function names. Or this guy is, if function is returning a boolean, a logical true or false, then is a good name for it. constants, we use all caps, so it's difficult to see where words start and words end. So we will use what we call a snake case. So snake case is words delimited by underscore, and to some imaginative developer, this looks like a snake. So use this for values that don't change. The fact that you're using caps will indicate that semantically it is a constant, not merely in the context of the program. So if you want to define a variable that wouldn't change, you can use constant with normal casing. But if it is something like max users or some API key, etc., those things are things that will not change semantically, and then you would use capitals with underscores in between. One thing to know is that JavaScript is dynamically typed, so you don't specify the type of the variable when you declare it, but the type is inferred from the operation. So here boo is this value, 1 is greater than 0, which means 1 is actually greater than 0, so it is true. So boo becomes true, that means boo is a boolean variable at this point. And then you can actually say after that boo equal to 5, then boo suddenly becomes a number. So things can dynamically change. First name in this case is going to be a string, and you can have arrays and objects. Objects are interesting, so let me spend a few seconds on this one. An object you can define on the fly using braces, and then inside the braces you have the property and its value. The value can be of any type, so it serves the purpose of a dictionary in Python, but with the caveat that the keys are actually properties of the object. Then there is this operator, typeof. It's not a function, it's an operator, language construct, which will tell you what the type of this next argument is. In JavaScript, you don't have different types of numbers. In most languages, you have floating point and double precision, integers, etc. But in JavaScript, you have only just numbers. So literal strings, string literals are strings that have double quotes or single quotes, and plus is actually a concatenation operator. So this statement here will result in a concatenated string like that. So strings have a property length. String is an object, that object has a property length, which actually keeps track of the length of the string. And here, this particular string, which is a literal string with double quotes, even then it's actually an object with the property length. So here 1, 2, 3, 4, length is 4, and that is the result. If you want to have double quotes inside a string, then outside you would use single quotes, or you could actually escape it. The escape character in Unix is a backslash. So backslash double quote is basically saying that, okay, don't use it as a double quote, is a literal double quote that I want here. So there is just one character that is double quote. That's the way it should be stored. Then you have arrays. So arrays are zero based, meaning this is the 0th element, this is 1, this is 2. So when you look for schools 1, the first element of the array, that is actually this guy. You could also use array. Why would you? Square bracket is perfectly fine, very clear, and easier to type in also. Notice that it's actually delimited by commas, not semicolons. Much like objects, object properties, here X is an object, the properties are separated by commas, not semicolon. Now arrays also have a property length and some methods, sort being one of them. So there are things that you have to be aware of when you say cars.sort and you're putting that in a new variable y. So y will be a sorted version of cars, but at the same time cars itself will be sorted internally. So the sort method actually modifies the array that it gets. So that's something important to keep in mind. Objects. So objects you can define them on the fly by using braces, and inside that you have properties with commas separating them. So they are name value pairs, and again notice that there is no quotation mark or anything around the property. Property names are just typed in there directly. They are not strings. So there's a little exercise here that you are supposed to do to practice. So just copy it and do this, and then run it and try to understand what's going on. This is for you to practice. Well, there's one thing I want to tell you anyway about this exercise, which you would have understood by now. That is this. You have cars defined as an array here, which is well and good. And then I'm going ahead and creating a new variable and saying that it's cars. Now, this guy is actually not a new array. It is actually referring to the same array, which means new cars and cars are pointing to the same memory location. What that means is that if I go and modify new cars, then the original cards also will get modified. Let's look at the second one here, person. You go and create a new person, which is a copy of a person, call it new person, and then original person, you go and change that to Prince. Then actually new person dot first name also will be Prince. This you would have seen in the exercise. So what it means is that the person variable and the new person variable are pointing to the same location, same object. So there's only one first name property there, whether it comes from person or new person. So dynamic typing, we went through that. You can create a variable at this point. X is undefined. Its type also is undefined. The moment you say x equal to 2, now x is a number. Then you go and say that x is a Brittany, and then x becomes a string. So quite a few examples here. So typeof is a language construct that will tell you the type of the argument that follows. So you don't need parentheses here because it's not a function, but of course parentheses doesn't hurt. In this particular statement, you might actually need parentheses because there is another operator here. This also is an operator. You don't really know the hierarchy, the priority of the operators. You don't know where typeof happens first or plus happens first. So you better use the parentheses to indicate what it is that you want taking place. So there are other functions called is-NaN. That also is interesting. That is to verify. NaN, by the way, is for not a number. So if you divide a number by a string, obviously that is not a number, so you don't know what it is. I think it is actually undefined, and then you can actually wonder what type of NaN is it NaN or is it something else? Verify that. So a bunch of functions to actually do type conversion. So if you have something like that, this is actually a number 123, and you can say make it a string to string. You can have rounding by using toFixed, and you can use a string to get the number out of it, and the argument, the string, if that happens to be something that is not really a number, then it'll say it's not a number. ParseInt is another one, so you get integers out of it, out of strings. But if it is something that cannot be converted to a number, then you will get NaN. So years 10 cannot be converted because the string there cannot be converted to a number, but 10 years on the other hand, it'll just convert whatever it can, and then it'll return 10. So these are things that you have to actually get used to, understand how these things work if you need to use them. Operators, so these are the operators, increment and decrement, that can be post or pre. There's some subtle difference between them, and then a bunch of operators. Please go through them and try to understand all of them. This operator, maybe I will spend a minute trying to explain this. So it is a question mark, some statement, and then some other statement. Let's do this in our where.html. We have where.html. We don't need this, so let me comment that out. Here I'm going to use let x be equal to 5, then let y be equal to, now watch this carefully, x greater than 5, question mark, then yes greater, otherwise no less. This is the statement. Then here I'm going to say, give one more argument, actually two more arguments, saying y now is, and then the value of y. I know that document write can take multiple arguments. How do I know this? If I just hover over it, it gives me the signature document write and says ... text, meaning it can take multiple text elements. So I'm expecting this to work that way. And I'm just, for the heck of it, I'm going to do the same thing in console also. Save this guy. Now, what do you think y will be? So what this statement is saying here is that if x is greater than 5, then say yes, it is greater. Otherwise say no, less. So x right now is 5. Is 5 greater than 5? It's not. It should not be. So I should get y equal to no less. So y now is no. That's what I expect to see. Let's see what happens. Y now is no less. So that's what it says. There's some spacing issues here and there. So let's actually correct that just for the heck of it. Now I can change this x greater than or equal to, now it should just say yes greater. So it says that. So that's what this operator does. This is called the ternary operator, and it's quite useful. Then logical and or negation. So those things you will get used to. We talked about strict equality. Strict will compare not merely the values but also the types. So if you try to compare 5 with string 5, loose comparison will say that, okay, this bozo is trying to compare 5 to a string. Let me help him by converting one of them to the type of the other. I believe in this case 5, the first 5 will become a string, and then the string 5 is the same as string 5. So fine, this is true. But if you use triple equal to, then JavaScript will try to compare the type first, then it'll say that, okay, it's not even the same type, so no point comparing the values. So this is false. So the second exercise for you to understand how these things work. Conditional branching is basically just another name for this if-else statement. This, I believe, you're completely familiar with from your Python exposure. So here the syntax is slightly different. It's got brackets there and braces instead of blocks intended in as in Python. In exercise 3, you will be implementing a simple calculator. The interesting thing there is the use of the function prompt to get values from the user. The next thing we want to do is something called exception handling. Exception handling is the way in which you can try a block of code, and if there is an error, you can handle that gracefully rather than let the program crash. So this is the syntax: try with braces, encapsulating a bunch of statements that you want to try that could typically have an error. Supposing you're writing to a file and you keep writing, and at some point, let's say you run out of the disk space or something, or the space allocated for this particular file, and then there would be an error. And if you don't have it inside a try block, the error is just going to terminate the program, and it may leave the file open, and it may not even flush the buffer that is full of, or something might happen, and you may not be able to use the things that were actually run properly until then. So the idea is that if there is an error, you capture that error and do something so that you can handle the error gracefully. So what happens is that you try something, and if there is no error, this guy, the catch part, is not used at all. After the try part is done, if there is no error, it'll come here, and if that block is missing, it'll just get out of the whole thing and it'll come here. If the finally is there, then it'll just run whatever is there in the finally part. So the flowchart will probably make it clear. So run everything in the try block. If an exception occurred, exception basically means an error occurred, then run the catch block, and after that run the finally block. And even if there is no error, then run the finally block. In our example, we said write something to a file which was presumably open here, and then if there is an error, come here, handle the error, say that disk full or whatever, and then in here close the file. It won't continue there, it will just exit after doing the finally part. If there is no error, if this guy runs completely fine, even then it will close the file here, and then it will continue with the next statement. So that's the whole flow. So try, catch, finally. So this is one example. So you're opening a file and reading it. So this is an open file statement, and you are actually dealing with the JSON, which is a data format for JavaScript that came out of the file. If something happens, for instance, user doesn't have a name property, if that doesn't work, and then it'll say that, okay, the JSON file is not valid, and then close the file. If you don't have close file in finally, then the file will be left open, which is a bad thing, especially if it is a write thing. For a read thing, it may not be that bad, but for a write operation, closing file is a good idea. And if you had the close file not in finally but outside, then that will not be hit at all if there is an error. And if you have the close file in here in the catch block, then it will not be hit if there is no error. So it has to be the finally block is actually necessary. Loop. So for loop, by specifying the starting condition, the termination condition, and how you increment it. So that is just that. So that is a very standard and a very popular loop construction. But there are other loops. For instance, if you want to loop through the properties of an object, you can use the in keyword. So for let prop is a dummy variable, in person. So you loop over each property of the person, the first name, last name, school, and age. And then it is writing person square bracket property. This is interesting. So person is an object, but we are using an array syntax to actually access the properties. This is valid in JavaScript, and this is actually quite useful. So what it will do is to look at the property of the person. First time it comes here, that's going to be first name, and person square bracket property is person dot first name, which is Haley. Then the next one is Belieber, and the next one is the school. So person school is actually the same as person dot school, and then SEI IS and then 20. So this will be printed out. Actually, I don't see a comma being printed out. So the whole thing will appear as just one big string, I believe. You can try it. Please try it and see. There won't be any comma because I don't see any comma being printed out. Then if you have an array, one way of looping over it, one way, of course, is to use a for loop and then use array.length to figure out how big the array is and then loop properly. Or there is a shortcut which is off. So again, shark is a dummy variable that you declare by let shark of sharks, then console.shark, and that will print out great white and tiger. And then let character of a string, then character will become each character of the string, which is nice. Here, this for loop is kind of trying to validate an email address by ensuring that at least this @ sign is there in the string that is passed. Then while is another loop. So get used to different types of loops, and I can imagine that maybe this off thing is going to be quite useful, and maybe the for loop, of course, the original for loop unit termination and increment, that loop is probably going to be quite useful. So complete exercise number 4 now. So given an array, loop over, etc., and then do those things. Now there are string operations. One of them is length, which we came across earlier. So alphabet in English, 26 letters. IndexOf being capital there, camelCase. So you can see an example there. Please locate where locate occurs. So 0, 1, 2, 3, 4, 5, 6, 7. So location is 7. That is the first time locate occurs there, not the last time. Keep in mind. Then last indexOf, of course, is the last place where it occurs. Play with it. I would think that last indexOf locate in this string will probably give you the location of this character there. Then there are other things like slices. So many functions, JavaScript and most languages that deal with web development are actually very rich in its repertoire of string manipulation functions, because string is what you're actually creating so that things can be displayed on your web browser. So there will be quite a few of them. So please be aware of them so that when you need to do something specific, you can probably guess that a corresponding function will be there. It's probably going to be impossible to memorize each one of them, but at least be aware of their existence. Then how they are to be used, etc. Visual Studio Code can actually help you. Trimming is a very interesting one that we will start using soon. Trim will remove the white spaces. So white spaces are either the spaces or tabs or whatever that you might have, or carriage returns or line breaks that you might have in the string in the beginning and in the end. So it will not remove this guy here, but it will remove this, and this. Substring is another thing. So you have to know the common ones. To lowercase, to uppercase, obvious names. Then replacing part of the string with something else. So understand that it replaces by default only the first match. I would imagine that there is actually a flag that will let you replace everything. But again, Visual Studio Code can help you, or devdocs.io can actually give you the actual signature. Split the string into an array. So if you have A, B, C, D delimited by commas, if you just split it using comma as a delimiter, then you will get A, B, C, D, and E as elements of an array. If you split it using nothing as a delimiter, then you get the characters. Push is to add something to the end of an array. Pop is to remove the last one and return it. Shift is to pop the first element and return it. So popping basically means it removes and then captures it and gives it back to you as the output of the function. Unshift is like push, but near the beginning of the array. Slice is to create a slice of an array. So if you have 0, 1, 2, 3, those are the indices of those elements. And new school, you slice it from 1 to 3, you get 1 and 2, not 3. 3 is not included. So that is important to remember. Then utility methods, you can check if something is an array. In this case, that will be true. Hello is a string which behaves like an array in certain situations, but it's not an array. It's a string object. Then number is an integer, so true. 5.5 is not an integer, so false. The number is NaN. If it is NaN, then true. And number is NaN. A string NaN, it is false. So you have to know these things. Object keys will just return the keys or the properties as an array. Values will return the values as an array, as you can imagine. Entries will return something like tuples, which are like 2-element arrays. So looping over array elements, one way is actually using a dummy variable of the array, so that will loop over each one of them. And then another one is to actually figure out the length of the array and then using a normal standard for loop. That is also pretty cool. Now in exercise number 5, you will check if the given string is a palindrome. Palindrome means it reads the same forwards and backwards. Right, so a normal function is defined using a function and the function name, an argument or a parameter, and it returns something. And it might do a lot of stuff before that, but it returns something. At times it might return nothing at all after having done a bunch of things, but that's okay. Functions are objects. That is something to keep in mind. Functions are objects. So you can call them to Celsius 32, that will return 0, that is the freezing point of water in Fahrenheit. That's fine. But at the same time, since it's an object, you can actually add properties to it. It may not make much sense to you now, but in a couple of weeks, you will see that that particular aspect of function objects is actually used. So to Celsius being a function can have a property called description dynamically attached to it, and that's kind of neat. Now, there are multiple ways of defining a function in JavaScript with very subtle differences. So let's start with a normal function definition, which is a named function that has a name and it's got parentheses which will bracket the arguments that you want to pass to that function. You will invoke it by just using the name. So it's all fine. This is you're used to. Then there is this anonymous function, which is starting here, a function with no name with parentheses indicating that it is a function, and then braces bracketing the body of the function, much like here. And now I'm saying let say hi. So I'm defining an anonymous function here and then defining a variable here using let, and then assigning that anonymous function to that variable. And at this point, say hi is a variable that contains a function, so I can just say hi and call that function, which will behave identically to this, but it is a let variable, so it's got the properties of let. Then there's arrow function, which is identical to this, except that you're kind of eschewing this keyword function and just saying parentheses, because some developers, being the lazy bugs that they are, realize that why type in this function, because the fact that I have a parenthesis there should be good enough to indicate to JavaScript that this is a function. And then in order to actually make it robust enough, because it's not good enough really, they use this equal to and greater than sign. That is why it's called an arrow function. And then the body of the function behaves identically to this. There's absolutely no difference between these two in terms of functionality. No difference. But between these two, there are subtle differences that we will not bother about at this point. One more thing I want to say is that you have these braces there, but if you did not have that, whatever you type in there will be returned by this arrow function. Let's say I wanted to define a function called give me 5. Okay, this is a function. I'm going to define this as an arrow function, and all I want to do is to return 5. So by right, I should be writing return 5. But an equally fine way of doing that is to say this, that will do the same thing. That will just return whatever is there. So that is another facility that JavaScript has. Functions are objects. So you can treat functions like just variables, and you can pass them around to other functions, for instance, or also they can become part of an object as properties. So in that case, you will actually call that a method. And in addition to that, functions themselves being objects, it can also contain properties and methods within. So that's all quite interesting. So let's take a look at the normal function that just says hi name. So name being the parameter that is being passed to it. So greet is the name of the function. After having defined the function, you can actually set a property called language, for instance, or set anything at all, any property. And here you're saying that this is English, which you might be able to use in some sense. So another function here, say hello. So hello name. Okay, so you have that function. Then you can have another function that says greet user. So greeting function, that is an argument and username. And here inside that function, I'm saying the message is a local variable using let. Message is greeting function username. So greeting function is expected to be a function that is being passed to it. And then I can console log that message. In step 3, I'm using it. I say greet user. When I say that, this function that says greet user will be invoked. and it takes two arguments. What's the first argument? That is say hello, and that is this object here, this function object there. So that will be passed to greet user. So greeting function at that point is the same as say hello, and that can be called with username. Username is Alice, so this name becomes Alice, then it becomes hello Alice exclamation mark, and the output is hello Alice exclamation mark. Instead of actually passing a named function here to greeting function, I might also start passing arrow functions there, and that might look a bit weird in the beginning, but you will get used to it because it's a very common pattern in JavaScript development. Then there is one more thing I have to talk about, that is actually the use of the keyword this. This facility is actually part of object-oriented programming. So we saw that we could create objects on the fly using braces, and you can have properties. These are all properties, and then you can have a property that is a function which is called a method. So this is actually a method. The add hobby is a method. The moment you have a method, you can refer to the current object as this. So when I say this here, what I'm referring to is this object user. You cannot use user inside because inside the braces it doesn't know what user is, but it does know what this is because this is the current object. So if I say this hobby, the moment I say that, this hobby is actually this property of the object user because this here stands for user. And you can push something, or if I just say console.log this.age, then it'll capture this. This is actually object-oriented programming, and this is actually very useful, and it's not merely useful, this is essential. This is the only way in which you can actually access the current object, especially when you're defining a class of objects, which is not actually part of something that will be tested in this course, but object-oriented programming is what most of you will be doing for the rest of your life. So get used to this. All right, now there are callback functions. They are passed as arguments. In greet user, we saw greeting function is being passed as an argument to greet user. Similarly, you can have standard functions that take arguments that are functions that you define. So let's take an example here. I am saying show message is a function. I'm calling it constant, even though semantically this is not a constant. I'm just saying that this function is not actually going to change. So I'm using it as a variable. You might as well use let. It's the same thing, but the fluent JavaScript pattern is to use const in such cases where things are not expected to change. Not semantically constant as pi or number of students in a class or those things, in which case you would actually use capital names, but this is like a variable. So this is a function. So this function just console logs a message. So message you want to appear after 3 seconds. So you say setTimeout, which is a part of Node.js or JavaScript, and the first argument there is a function that you want to run after so many milliseconds. So this will actually work, but you might actually see this as a setTimeout, an anonymous function with 3000. That looks a little cooler, and it might even be an arrow function. So let's do this just for the heck of it. Let's try doing this. So I'm going to use my where.html. I'm going to remove everything inside here and copy and paste whatever we saw there. There's some random characters that I get rid of. Okay, so show message is just a function that does this, and then set timeout in 3 seconds. I'm going to run the show message function, and let's delete or comment out this for a second, and this is it. This is what I want to do, and let's run this. I'm going to run this in Chrome, nothing there in console. 3 seconds later, this message appeared in console. Let's make it a bit fancier, not merely in console. Let's actually do document write also, which means it will appear in the body. So document write. Okay, I'm reloading this, nothing here in the body. 3 seconds later, this message appears here, and same message appears here in the console. So that's what the timeout does. And if you don't believe me, it's 3 seconds. Let's make it 5 seconds, a bit longer. So obviously, I changed this to 5 here. Actually, while doing this, let's also do one more thing. This is an anonymous function. So let's use the arrow function syntax. So that is this, and run this. So 5 seconds. Cool. Now, this is just an arrow function from here to here. So instead of having show message as a name function, I might as well have it like that. That That means I don't really need the show message defined that way. I'm just doing that thing right there. And that will work identical to this. And that's the way you will most likely see it in all kinds of standard code. So get used to this one. So what's happening is I thought the explanation wasn't that clear. So I thought I would do this once more. So ignore the technical terms there. These all came from ChatGPT because I wanted a better explanation. So ignore those guys for now. So what happens is that when you say set timeout show message, it starts a timer, but it returns immediately. So it starts internally a timer, and whatever statements you might have after that, they are all running. All the synchronous code is synchronous because it's step by step, but asynchronously in the background, the timer is running. When the timer expires, it will actually ask JavaScript engine to run whatever I queued there as show message. And when it gets a chance, it'll actually run it. Hopefully it'll run it right after 3 seconds. But if there are other things that are being run that are time consuming, then it might take a little longer. So what it means is that wait for at least 3 seconds, and right after that, whenever you can, run this function. That's what it means. Now, there are many such callback functions that you can use. One is this facility of filtering arrays. So you have an array here and you can filter, and that filter method of an array object will take a function. You can have a function there, and what that filter does is whenever this function returns true for each element, then that element will be cut. So I have my function here. It takes a dummy variable value and an index and an array. So it's ignoring these two guys. So those two guys might as well not be there. So ignore those things. And let's say it takes only a value. And whenever the value is greater than 18, it will return true. And whenever it is less than or equal to 18, it will return false. So the return value of my function is true whenever the value is greater than 18. Otherwise, it's false. Now, this function is being used as the filtering function here, which means this call here will walk through the array. For each element there, you'll call that function with the dummy variable value equal to that element. So whenever that element is greater than 18, it will be true. So this element will be saved, this element will be saved, but these guys are all less than 18, so they all die, and the return value will be this 45 and then 25. So that's what filtration does. Then obviously this is a named function. You can also have this as an arrow function. Let's do this one also in our Visual Studio Code because I want to show this to you. So I copied that, and after a little bit of editing, I am hoping that my result will be just a filtered version of that. So we have to see it. Let's actually document write it. Document write result. So I get 45 and 25 as expected. What I wanted to show you was the fact that this guy is a function. It's just a function with the name my function. So you could actually use an anonymous function, in particular an arrow function, which takes value and returns value greater than 18. Now I told you that when there is something here not within braces, then that thing will be returned. So what's going to be returned? Whenever value is greater than 18, this will turn out to be true, and that will be returned. So in effect, this is the same as writing. So I'm deleting this. The same as writing, return that. So let's do it that way first and see that we are getting the same. Just to make sure that we are changing something, let's put 35 there. I'll have 3 elements here that survive the filtration process. So I should see 3 of them there. I do. Now, like I said, I didn't need to have this return statement. I could just, if I have braces, then I do need a return. If I don't have braces, then whatever is there will be returned. And that is typically returned like this. So it looks like that. Much cooler, much more cryptic. And again, in order to make sure that we have changed something, let's make this 35 and add one more 70. So that's the same thing. So this is very common, walking through an array and doing things. So there are things like filtration, sorting, and mapping, etc. So you will have to use those things. So here are a couple of examples. Take a look at those examples and understand how they work, because those can be very powerful. As we saw some time ago, a property of an object can be accessed just by typing in the property. For instance, user.name. User is an object, okay, and name is as a property. You can get it like that. Or you could use this array kind of syntax, which is actually quite useful in certain situations. Again, you will have to see some examples, which you will later in life in a couple of weeks. And that's when you will understand that being able to access this way is actually quite nice. Modifying also is using dot. This is probably completely fine when you're actually writing code, but when you're doing something programmatically inside a loop, maybe the second way might actually be useful. So that is exercise number 6 to do these things. So for each, array.forEach is you run a function for each element of the array, and here I'm just printing out whatever that element is plus 1. So for each, we'll take a function with this dummy variable element, which stands for each one of them in turn, as the method array.forEach is actually walking through the array. So it becomes 1 first, then 2, then 3, and then it'll take 1 will become 2 because element plus 1. So 2 first, 3, and then 4. Again, I don't see commas there, so the commas will not be there most likely. So it's probably going to print out 234. For the sake of completion, although this topic is actually not going to be tested directly in your lab test or the final exam, I thought we would go through this classes and objects, which actually forms the backbone of object-oriented programming. We have already come across objects. They are things that are similar to a dictionary in Python. So key-value pairs, except that key is not a string, is a property of the object. And then in addition to that, we saw that some of the properties can actually be functions, and then since they are functions, they are called methods. So an object can have properties and methods. Now, the standard way in most programming languages this thing is done is by defining a class of objects and then saying that this particular object is an instantiation of that class. So class is like a blueprint, and an object is like an instance of that blueprint. Or another analogy is a class is like a cookie cutter, which doesn't really have any data or cookie in it. And using the cookie cutter, you can cut many cookies. So cookie cutter is like a blueprint using which you can create many objects of different properties, so different ingredients. So it's like a template. A class is like a template, and a specific object is actually an instantiation of it. So the way it is done is by defining a class. As you see here, a class student starts with a brace encapsulating the whole class, and it's got a special method called constructor and another method called introduce, and it creates properties like this. So the moment you say this, at this point, realize that there is no object yet. This is like a definition. It's like a function. Suppose you have a function which has an argument x. That x doesn't have a value yet. When you invoke the function, that's when it gets a value. That's why it's called a dummy variable. Similarly, a class doesn't have an object associated with it when you're defining it. Later, when you actually use it, that's when it gets values, and that's when it has an address associated with that object. So you cannot actually use any name of the instantiated variable. Here, you have to use this. This basically means the current object that you're working with, and that has a name which will come by calling this constructor method, which gets dummy variable called name and the dummy variable, a parameter called school, and those will be associated with the current object. So class is a blueprint, and how do you use it? So let's say student1, S1 is a new student, and I'm giving a name Haley and giving a school SEIS. At that point, when I say new basically says call the constructor. I call the constructor, and then for the current object, which is S1, put name equal to whatever I passed as name here. In this case, it's actually Haley. So Haley comes in there. That becomes the name of S1. Similarly, S2 has a name Jizu, and then the school also. Similarly, S1 has a school SEIS and S2 SOSS. Then you can invoke the method by just saying S1 dot the method name with the parenthesis, and that will just console log this name, whatever the name of S1 is at that point when you are hitting this line, and that would be Haley. So it would say Haley from SEIS because this school, and in that case is actually SEIS. On the other hand, when you come and hit this one, it will again go to introduce method there, but at this point, this name is actually Jizu, and this school at that time is a SOSS. So that's what will be printed out. So this roughly how it works. And that is something that will be useful not merely for this course, actually not so much for this course, but for the rest of your life, because every big program, every big application in the world is written using object-oriented method, nothing else. And there are sound reasons why that is the only way in which huge software projects can be run. So this refers to the current object. That's all you have to remember. So that brings us to the end of the first of our JavaScript lessons. In this one, you learned the basics of JavaScript syntax, and then we moved on to slightly higher order concepts like try-catch and also the basics of object-oriented programming. All these things will come in handy later on, especially things like the arrow functions and also the fact that a function is actually an object which can take properties, and all those things will be used later. So all the best to you as usual, and I shall see you later.